So we're going to go through a few examples of free response questions on this topic of particle motion. And the first one gives us both a graph and it gives us a table. And the graph is for velocity. So we want to be very careful, right? This graph is for velocity. So it already is the graph of the derivative of position. We want to be careful about that. It's kind of similar to having the graph of f prime. They give us an interval from 0 to 50, and they give us values in the table. The first question says, during what intervals of time is the acceleration positive? So we need to kind of go back, and this is something we need to just start making the connections, okay? So our, you can add this onto your notes somewhere, is, let's go before this page, somewhere you can kind of fit this in, would be that, essentially with f of x, right, is we kind of knew that if f of x is increasing, then f prime of x was positive. Well, this would be that our position is increasing, which a lot of times means, moving to the right. And so that would match with our velocity being positive. Okay. Same thing for position decreasing. Moving left would be velocity negative. Right? If our position is stopped, we're at rest, that's when our velocity is 0. Okay, and then for f of x concave up, we said that matches up with f double prime of x being positive, but then we added on a third thing that also matches up when f prime of x is increasing. So when we connect this to position, right, if the position is concave up, right, that kind of means that the position or a particle is accelerating. Right, that would be the words that they might use. The particle is accelerating. Then we're going to know that our second derivative will be positive, which also means that our velocity will be increasing. Right, and then same thing, decelerating would be velocity is negative. So they ask, when is the acceleration positive? Well, that would be when the position is concave up, but we're not given position, we're giving velocity. So that would be when the velocity is increasing. So whenever this velocity is increasing. So it looks like we're increasing, we're going up, 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 all the way until this point up here. And then we start decreasing. But then again, we increase again. So it's increasing and increasing. So we will say that basically acceleration is positive for 0 to, it looks like, is that 35? Union from 45 to 50, because the velocity, or you could say v prime of t if you want to, is increasing for those intervals. Right, find the average acceleration. So our average acceleration formula, remember, was v of b minus v of a over b minus a. So our average acceleration will be equal to v of 50 minus v of 0 over 50 minus 0. So I'll use the table. V of 50 is 72 in the table, and v of 0 is 0. So 72 minus 0 over 50, and they want us to indicate units. So I'm going to leave this as 72 over 50. You could simplify it, right? You could make it like 26 over 25, but, sorry, 36 over 25 if we divide both sides by 2, but you don't have to, right? On free response, I like to just leave it. But now we do need units. So velocity was in feet per second, so acceleration will be in feet per second squared. So again, 36 over 25 would be fine. I'm going to leave it like that, though. Find one approximation for the acceleration of the car at time 40. So remember, we talked the other day about approximating. We can either approximate the value that we have using a tangent line, or we can approximate the derivative, with y2 minus y1 over x2 minus x1? Well, do we have acceleration? No, acceleration is the derivative of velocity. So that's kind of our big takeaway that we want to be remembering here. Is kind of, we have position, we have velocity, and we have acceleration. And each time you kind of go down, you're taking the derivative. So when we approximate a derivative, right, we do y2 minus y1 over x2 minus x1. Now at time 40, so we would kind of be going around time 40. So I'm going to use 35 and 45, right? Those are like around 40. So I'm going to say that essentially acceleration at 40 would be equal to the v prime, right, the derivative at 40. And so we'll say this is approximately v of 45 minus v of 35, right, y2 minus y1 over x2 minus x1. So v of 45 in this case, if we look on our table, is 81. V of, 60, I think it's 60. I think I got those backwards. Yeah, 60 minus 81 divided by 45 minus 35 is 10. So we get negative 21 over 10. You can make that negative 2.1 if you want to, but I'm going to leave it as negative 21 over 10. Again, units would be feet per second squared because we took a derivative, right, like a rate, or because it's acceleration. So that would mean we're decelerating at 40, which kind of makes sense because if we look up at 40, right, our graph is decreasing. We said that would be acceleration negative. Is the speed of the car increasing or decreasing at time 40? So remember, speed increasing or decreasing is based on the signs. Are they positive or negative? So we're going to say v of 40, right? V of 40, if we look up on the graph, v of 40 is 75. So I'm going to say v of 40 is 75. That's greater than 0. And then we know that our acceleration, now we don't know what our exact acceleration is, but we know that our acceleration is approximately negative 21 over 10, which is less than 0. So we'd say that the particle, or it's a car, sorry, this one's a car. So the car is slowing down, right? Oh no, yeah, they're opposite speeds. So our car is slowing down, or you'd say the speed of the car is decreasing if you want to. That would be the same thing. At time 40, we always want the at, because, and then I'm going to say v of 40 is greater than 0, and a of 40 is less than 0. And that's all you have to say. You don't have to add anymore. That's totally perfect. The graders will know that you know what you're doing. Now, if you want to say, you know, opposite signs, you can. So sometimes I'll have students who kind of add that just to bring it home. Okay, next up, this is from 2000 AP exam. So we have two runners running, runners A and B, and they're running on a straight track from time 0 to 10. Then the graph is below, and that's for runner A. And then for runner B, they instead give us an equation. And remember what I told you guys is anytime you have a question that's number 1 or 2, that was always a calculator question. So this you're expected to use a calculator. Right up here, this was from question 3. So this one actually was a calculator question because it was from 1998, but we didn't really have to use it too much. But this one definitely will be a calculator question. So find the velocity of the runner at of runner A and the velocity of runner B at time 2. So the velocity, you know, of A at time 2, right? We can just look on our graph. If we kind of look on our graph, you know, you may want to count a little bit and get an equation. Because if we look on our graph, this is what makes this one a little bit hard, is it's really hard to tell, like, is that at 6, is that at 7, is it a little bit in between? So this one was a little bit tougher. So in order to do this one, I'm going to kind of say, okay, runner A, well, we know that that's a straight line, right? So we can kind of do y minus y1, I'll use 10. Actually, let's use the point 0. 0, 0 is an easier point to plug in. So let's use y minus 0 equals, now we need the slope. The slope is up 10 over 3. So equals 10 thirds times x minus 0. Right, so we get y equals 10 thirds x. And if you want to make that into equation, you could say that v of t would be equal to 10 thirds times t. Right, so we're plugging in time 2. So at time 2, we would get 10 thirds times 2, so we'd get 20 thirds. So v of 2 is 20 over 3, and then our units are in meters per second. This one was a little bit tricky right there. Okay, and then the velocity for b at time 2, that one's a lot easier. That one we're just going to plug in 24t over 2t plus 3. Now, because it's a calculator question, if you want to make sure you don't make a mistake, then you can just use your calculator. So you can say, control divide 24t divided by 2t plus 3. And you can do at time equals 2. Now, if you did this in your head, that's fine. But just, when you have your calculator, using it is pretty smart. So we get 48 over 7. So b of 2 was 48 over 7. And again, same units, meters per second. All right, B says to find the acceleration for runner A and the acceleration for runner B at time 2. So the acceleration is the derivative, right? So the acceleration of runner A at time 2, I like to kind of write is equal to v prime of A at time 2. Well, on a graph, how do we find v prime? On a graph, we find it from the slope. Okay, that's very important. Whenever we have a graph, we take the derivative based on the slope. So the slope of this line is up 10 over 3. So we'll have 10 thirds meters per second squared. Right, I'm going to say that one more time. On a graph, we always find the derivative based on the slope. Okay, and we can even add this, maybe put this in your notes somewhere. On a graph, we get the derivative from the slope. On the equation, right, we get the derivative basically by doing, power rule, product rule, etc., right, chain rule, basically taking the derivative. If you're ever given a table, you can't do the derivative, but you can approximate the derivative with what we did in the previous one, y2 minus y1 over x2 minus x1. That's what we did at time 40, right? We approximated the derivative. So that's important to make sure we know. So now for runner B, the acceleration of runner B at time 2, that's going to be v prime of B at time 2. And again, you don't have to show any work because it was a calculator question. If it was a non-calculator question, we would have done a quotient rule, right? This is, a quotient. So we could have done quotient rule. But because it's a calculator question, we can say, okay, let's do the derivative with respect to time t of 24 over 2t plus 3. Now make sure that you move that at to the outside of the parentheses. That's important. The at always has to go outside of the parentheses. And we get 72 over 49. So 72 over 49 meters per second squared. And that's all they asked. Now, moving on. This again is number 3, but it's from 2002. So that would have been with a calculator. So an object moves along the x-axis with position x of 0 equals 2. And then the velocity is given by this function. They don't use units here. So if they don't use units in a question STEM, right, and it's STEM meaning like it's instructions, then you don't need to report any units. So what is the acceleration of the object at time 4? So we can say acceleration at 4 would be equal to v prime of 4. Now, you can use a calculator. I'm going to not, just so we can kind of practice this a little bit. So v of t would be sine of pi over 3t. I know it's been a long time since we've worked with these. So acceleration of time, that would be the derivative. Well, the derivative of sine is cosine, but this is not x inside, it's something else. So we're going to do cosine of pi over 3t, then times the derivative of pi over 3t, right? Pi over 3 is just a constant. So what would be like the derivative of 2t would go to 2. So the derivative of pi over 3t is just pi over 3. So the derivative of pi over 3t is just times pi over 3. So there's that. So now if we wanted to get a of 4, right, which is v prime of 4, we just plug in 4. So we get cosine of 4 pi over 3 times pi over 3. And the cosine of of pi over 3 is 1/2, but then we want to do like the all students take calculus. So 4 pi over 3 is 1 more. That's in the third quadrant, right? 1 more than the denominator. So we'd be at negative 1/2. This would be negative 1/2 times pi over 3, and we get negative pi over 6. Now, you could have also just done this on the calculator, right? So on our calculator, we would have done our derivative tool, right? The derivative of t with respect to t of sine, don't type it, right? Use the trig, sine of control divide. There's our pi button down on the bottom left. So pi over 3 times t. And we want to do at time equals 4, right? And we'll get negative pi over 6. Right, same answer. So now consider the following two statements. And if you had put that as a decimal, if you'd done control enter and done a decimal, that's fine. So statement 1 says for 3 less than t less than 4.5, the velocity is decreasing. And statement 2 is for t is less than 3 less than t less than 4.5, the speed is decreasing. Are both statements correct? And we need to kind of come up with a reason. So this is a little bit tricky, but we just kind of want to kind of think that, okay, we know about v of 4, right? Or sorry, a of 4, the acceleration of 4. So the velocity decreasing, that means that acceleration is negative. That's literally what that means. So if you ever see velocity decreasing, that matches up with acceleration being negative. If we see velocity increasing, that matches up with acceleration being positive. So statement 1 seems to be true because a of 4 was negative, right? So kind of for statement 1, right, we knew that basically v prime of 4 equal to a of 4 was less than 0, it was negative. So the velocity should be decreasing. Now that's only at time 4, so honestly it would probably be a little bit smarter to graph this and just kind of double check it. So, you know, if we went over to our graph and we graphed pi over 3 times t, and we're going to change t to x because we're on a graph, right? And I'm going to change my zoom, my window zoom, to be from 3 to 4.5, right? That's what they give us. So from 3 to 4.5. So we see this entire time from 3 to 4.5, our velocity, this entire time is decreasing. We don't care if it's positive or negative, we just care that it's decreasing, right? Acceleration will be the decreasing of it. If you really wanted to, what you actually could do is you could also graph the derivative of that. So we could do the derivative with respect to x, and then you could type all that in. I think you can actually do this though, f1 of x. So that's our derivative. So our derivative the whole way in red, right? Red is the derivative. Red would be the acceleration. It's always negative, right? The red is always negative. Or you could say the blue, right? The velocity is always decreasing. Either one of those would describe our acceleration. So statement 1 is true, right? Right, so I kind of did it with v prime of 4 here, but a better way to say would be that, you know, velocity is decreasing for 3 less than t less than 4.5. Then for statement 2, right, or you could have said like acceleration is negative, that red graph. The speed of the object is decreasing. Okay, so we want to know what is v of 4 and what is a of 4. Well, we already know what a of 4 is, right? A of 4 was negative pi over 6. Well, for v of 4, right, we can just plug it in. So I already have it graphed here, so I can do the trace button. So I can do the trace button for the blue graph, that was our V graph, and just type in 4, get negative 0.866, right? Or, you know, we could have also gone back here and just done, you know, sine of pi over 6. Sorry, pi over 3, right? Yeah, pi over 3. Right, that's our original, and then, you know, our velocity at time equals 4. We get negative square root of 3 over 2. So, you know, either way you do that, negative square root of 3 over 2. So these have the same sign. So this statement, when they have the same sign, we know that we're speeding up. So this statement will be false, right? Because the object is speeding up at time 4 because velocity at 4 is greater than 0 and acceleration at 4 is greater than 0. Right, they have the same sign. So I know this was a lot of notes, a lot of examples before we start this homework. Normally when we're in class, we actually get to spend like three to 4 days on this. But this time we're really only spending a couple days on it because we had to take the entire semester and squeeze it down, right? The entire year, sorry. We had to take from August all the way to May, and we had to squeeze that down into one semester. So it did move a little bit faster. If you need to rewatch these videos, you can. That's kind of why I'm giving you guys the weekend to try day 43 homework, to ask questions, to go to Mr. C's session. And we will get some more practice on it as well. But if you're really confused on anything, please, please, please either post on the classroom that you're confused and you need help on a certain part, or send me an email that you're confused and you need help on a certain part.